Hello, and welcome back to Introduction to Astronomy. In our last segment, we were talking about Newton's laws of motion. And so Newton's laws of motion can be used to describe the motion of an object. Well, another way of rewriting Newton's laws of motion is by using the concept of linear momentum. Now, linear means, again, that it's going sideways. So momentum is defined to be mass in motion. So we abbreviate linear momentum with the letter P, and its formula is going to be P is equal to mv. So you take the mass of an object, you multiply by its speed, and then that will be the momentum of that object. So if it's not moving, how much momentum does it have? It would be 0, because 0 times anything would be 0. So if I was to say to you, what's the momentum of the Queen Mary if it's docked? Well, you would say 0. But the Queen Mary's so big, it's got a lot of mass. Yeah, but if it's not moving, if it's docked, then its speed is 0, and 0 times anything is going to be 0. So how could we rewrite Newton's laws of motion in terms of momentum? Okay, so his first law of motion would be if there are no outside forces acting on a system, then the momentum of that system will remain constant. Okay, it's going to not change. It's going to be conserved. So all three of those mean the same thing. So to mean it's conserved means you can't create it and you can't destroy it, and it's not going to be changing. So an example of that is that picture down there at the bottom of the gun firing. Okay, so imagine that at first the bullet is still in the gun and the gun is not been fired yet. What's the speed of the gun and the bullet? It would be 0. So it's not moving. So what's its initial momentum? 0. So 0 times anything is 0. So if the gun's just sitting there, it has no momentum. Now, according to Newton's first law of motion, if there's no forces acting on the system, then the momentum isn't going to change. Okay, so now let's fire the gun. When we fire the gun, you'll notice that the bullet comes out going to the right. So let's say that's positive, and it has a certain mass m, and it's going at a certain speed v. So we could multiply the mass of the bullet times the speed of the bullet, and then that would be the momentum of the bullet traveling to the right. So let's just say, for the sake of argument, it's 3. So if momentum is going to be conserved, remember that it started with a momentum of 0 before you pull the trigger, and now all of a sudden it's got a momentum of positive 3, then that must mean there needs to be a negative 3 in order to balance it. So that 3 plus negative 3 equals 0. And that's what the gun does. So the gun goes backwards. It goes to the left as the bullet goes to the right. And so we could even compute the momentum of the gun as being the mass of the gun times the velocity of the gun going backwards. And so if we could measure the mass of the bullet, and we could measure the speed of the bullet, and if we could measure the mass of the gun, we could take those three numbers, plug it into that formula, and we could figure out the recoil of the gun. How fast would the gun be going to the left? Okay, now let's look at Newton's second law of motion. So Newton's second law of motion means if there is a force acting on the system, then the system is going to change. And so that formula says a force changes the momentum of a system per unit time. So it's change in momentum divided by the amount of time it took for it to happen. So an example of that is the picture that's right next to it, and that would be the baseball player. So you have a baseball that's coming in from this direction, and it's got a certain momentum. So that would be the mass of the baseball times the speed of the baseball. Okay, now after the baseball player hits it with the bat, now the ball is going this way with a certain momentum. The mass of the ball times the new speed of the ball as it's going that way. So what did that? So what caused the momentum to change? If the momentum had not changed, the ball would have just continued to go like that. So the momentum changed because it went this way and then it went that way. Well, what changed it was the force of the bat acting on the ball. So we could, in theory, measure the speed of the baseball as it's going this way, the mass of the baseball going this way, multiply them together. That would be the momentum of the baseball initially. Then we could measure the speed going this way and calculate the momentum after, and then we could find the change in the momentum. Okay, that's the delta P. Now the next part is, though, we would need to know how long the baseball bat is in contact with the ball. That would be the T. So you could put that in there, and then you could actually calculate the force of the bat on the ball if you did that. So we're not going to do it, but I just want you to see it can be done and how useful this concept of linear momentum can be. Okay, we're going to take a break, and when we come back, we're going to start talking about things that are rotating.